Today I'm going to read an article called What is Ocean Acidification? While you're listening to this, be thinking of some connections that you can make to what you've already learned about acids and bases. Also, periodically during my reading, I will ask you to pause the video to answer some questions. Carbon dioxide, CO2 gas, is a gas. It is released when animals breathe out. It is also released when people burn fossil fuels. These fuels include gas and coal. Some of the CO2 released into the air ends up in the sea. It gets absorbed by seawater. When CO2 mixes with seawater, reactions take place. These reactions have a few key effects. They cause seawater pH to decrease. The pH is a measurement. It measures the acidity of a water-based solution. A lower pH means a more acidic solution. The reactions also reduce the quantity of calcium carbonate minerals dissolved in the water. The reactions have a name. They are called ocean acidification. Pause the video and answer the question, what are some of the key effects of these reactions? So you should have recognized that when I asked the question, what key effects do the reactions have, you would highlight, if you're reading, they cause seawater pH to decrease. The pH is a measurement, tells you that. Then that's not relevant. A lower pH is more acidic. These reactions also reduce the quantity of the calcium carbonate minerals dissolved in the water. Those are some key effects. They cause seawater to decrease, the pH to decrease, and they reduce the quantity of calcium carbonate minerals dissolved in the water. Okay, I'm going to continue reading now. Calcium carbonate minerals are important. They are the building blocks for shells and skeletons. Many saltwater organisms have these structures. Some parts of the ocean are rich with life. In these parts, seawater has plenty of calcium carbonate minerals. The minerals are dissolved in the seawater. Ocean acidification changes this. It decreases the amounts of these minerals. This makes it harder for sea creatures to build shells and skeletons. The pH of surface ocean waters has changed over time. In the past 250 years, surface water's pH has fallen. It has dropped by 1/10 pH. This means ocean acidity has increased by about 30%. Scientists predict acidity will continue to rise. Stop and note what has caused the ocean waters to change over time. Scientists expect ocean acidification to affect different organisms in different ways. Some living things may actually benefit. Sea grasses and sea plants are two examples. These organisms photosynthesize. Just like plants on land, they take in CO2 to make nutrients, so they need plenty of CO2. More is better. Other organisms may not do well. Many saltwater creatures rely on calcium carbonate. They use it to build their shells. These creatures include oysters, clams, and corals. These species and many more may be in danger if calcium carbonate decreases. Below are examples of creatures that may be affected by ocean acidification. When one creature is at risk, the whole ecosystem can suffer. So readers, this would be a good time to make a chart from this section alone and identify the answer to this question. Which organisms are affected in a positive way, and which organisms are affected in a negative way by this change in the pH in the ocean? All right, let's keep reading. The pteropod is a tiny sea creature. It's also called the sea butterfly. It's about the size of a small pea. Pteropods are eaten by many organisms. Tiny krill snack on pteropods, so do enormous whales. The sea butterfly is also a food source for young salmon. Ocean acidification may harm the pteropod. Scientists predict that the sea will be much more acidic by the year 2100. By then, it could be acidic enough to dissolve a pteropod's shell. Breaking down the shell would take just 45 days. The pteropod cannot survive without it. This will not harm only the pteropod. It could also impact the many species that eat the pteropod.
Recently, oyster production has been failing on the West Coast. The failures seem to happen during natural upwelling events. In these events, deep, cold waters flow up to the ocean surface. They replace the waters near the shore. These new waters have a low pH. They also have low levels of aragonite. Aragonite is a calcium carbonate mineral. Lower pH values are natural during upwelling. However, higher CO2 levels may make the effects even worse. Scientists have studied the oyster failures. Their findings suggest that CO2 from human activities cause a decrease in aragonite during an upwelling. This may make it hard for oyster shells to form. Low pH may be one cause of the current oyster failure. More study is needed to know for sure. We do know one thing for sure. Oyster production is a very big business. It brings in lots of money for business owners and workers. So the effects of oyster failure are not only environmental, they are also monetary. You may notice that I've added a question in the margin. How are shellfish impacted by ocean acidity? Go ahead and think back to that. Can you answer that question? We're going to read on and read more about coral. Coral are also at risk from acidification. Higher acidity in the sea is dangerous to coral. It makes it harder for corals to build reef structures. Scientists have studied corals and acidification. Some studies show that ocean acidification could make it harder for coral reefs to recover after disturbance. Other studies suggest that by 2100, coral reefs may break down faster than they can rebuild. This threatens coral reef ecosystems. 1 million species depend on these habitats. Ocean acidification could affect them all. An emerging global problem. Ocean acidification is becoming a global problem. Many ocean scientists have been studying its effects. They are just starting to track ocean acidification. Scientists do not yet know exactly how acidification will affect ocean ecosystems. They are doing more research to try and find out. With help from the science, they can decide what to do. Their decisions could help protect our seas. Boys and girls, now that I've stopped reading, I would like you to think about 3 questions here. What is ocean acidification? How is low pH affecting the ocean ecosystem? And why is this a problem? And who is this a problem for? I'm sorry, that was 4 questions. So be thinking about those things for your upcoming project that I will reveal tomorrow. So you need to become a little bit of an expert on acids and bases, and this just helps you understand the connections between what you're learning about the pH scale and how it connects to the global world around you.